We are talking about um, context-free languages, showing that something is or is not context-free. Now, the is not so hard. You just make a grammar for it. To show something is a context-free language, you make a context-free grammar. To show it is not, that is much harder, and you need what we call the pumping lemma for context-free languages. And so today we are, I don't know if we'll get to it, the lemma itself, but we're on that road. All right, and what we were talking about at the end last time is this fact. In any context-free language, each string has a parse tree. Well, really, this is, can I say instead of context-free language? Did that again. I hit the paint bucket instead of the eraser. Any context-free grammar, really the parse tree is based on a grammar, a specific grammar. So if you have a context-free language, of course, there are many possible ways you could write a grammar. But when you write a specific grammar, you can use that grammar to create parse trees for any string. So, for example, I did an example at the end last time. Here's another example, and then I want you guys to try one. Here is a grammar. S goes to AST or T. T goes to BT or epsilon. And I would like to make a parse tree for the string AABBB. All right? So first of all, I'm going to make a traditional grammar derivation for that string. Well, I better begin with AST. Is this the same example I did last time? Yeah. Oh, sorry. I'm back in my notes by one page. Let me just real quick go through this because I wanted you guys to do one, and I don't want to leave you hanging here. How to get AABBB? I have to go to AST and then AST again, so it will look now like AAST. And then the S can become a T. Sorry, actually, maybe this is the same as last time, but I'll do it differently this time. We can do it. The way that I did this example last time is not the only way to do it. I don't think. No, it's not. How about let's now make the S become the T. So now I have A, T, T, A, T, T, T. I think this is still the same as I did it last time, but here I'm gonna finish it off differently. Let's make that first T into a BT, and I'm gonna make the others into epsilons. All right, and then I'm gonna make that T into another BT, and then another A, B, 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 T, and then finally T goes to epsilon, and I get A, B, 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 epsilon. All right. If you look last time, the derivation I did here is different, and actually it's going to give me a different parse tree from what I got when we did the same kind of example last time. All right. Anyway, how you write the parse tree is it's going to be sort of a big kind of vertical thing here, and it starts with S at the top, and every single letter gets to be its own like node in the tree. So S becomes AST. Every single letter becomes a thing in the tree. And then, next step, the S became another AST. All right. And then the next step, the S became a T. So I'm following step by step in this derivation, but writing it as the tree form. Okay, and then in the next step, the first T became BT, and the other two T's became epsilons. So this, like that, these became epsilons. All right, and then the next step, the T went to a BT, so it turned into that. The next step, it happened again. Oops. And then finally, this T became epsilon, and that was the end of it. All right. And you can see the string you read kind of across the bottom, by which I mean you follow every little branch all the way down as far as it goes, and you read from left to right. And what you get is sort of this. A, B, 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 epsilon, epsilon, epsilon. All right? This is called a parse tree for that string. Now, I did the same example last time, but the derivation strategy was slightly different, and that led to a different parse tree, even though I got the same string. All right? Any questions about that? This is how you do a parse tree. You can beautify this if you want by putting, just to make it look nice, I can write the string at the bottom, A, B, 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 and then just because I know there's going to be some epsilons. And you can sort of make it look a little nicer. This S turned into this. S, another T. This T became epsilon. My hand slipped there. I didn't mean to make that. And then it's like this. I hope I don't run out of room here. There, perfect. It fits perfectly. All right, this is a nicer looking thing. You can clearly read the string at the bottom. Okay, I want you to try this. This is not hard to do. I just want to make sure everybody is with it. So here's a grammar. S goes to A, S, A, or T. T goes to B, T, or B. And I would like you to draw parse trees for, I have some strings for you. Draw parse trees for A, B, B, A, B, 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 and A, 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 B, B, A, A, A. See what you think. I will walk around and see how you're doing. You may want to write a grammar derivation first, or you might be able to just jump to the tree, that's fine. I'm going to do mine slowly. All right, shall we talk about these? I don't know if you're done yet, but once you get the hang of these, I think they're not especially hard to do. You just gotta do them. So the first one here, to get A, B, B, A, you want the S to go to ASA, and then the S becomes a T in the middle. That T becomes a BT, and then this T becomes a B. And it should look like that. I hope you got something like that. All right. One nice thing about parse trees is when you are writing grammar derivations step by step, there's actually some amount of choice, especially in terms of the ordering of the steps. Exactly what you do and in which order can make your answer look different from somebody else's if you're writing a grammar derivation. But everybody should have written the same tree. Actually, there is no other parse tree that gives you that string in this example. So in a sense, the parse tree is a little less ambiguous, or it's more, well, maybe more ambiguous. It's less specific because derivations can be done in different orders when really you're talking about the same thing either way. All right, here's I decided to draw this one in the cute way. I hope that's what you got for B, 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 B. Question? Yeah. Did I mess it up?
S goes to T.
S goes to T. Oh, yeah. So, yeah. Thank you. There's a, yeah, you can nitpick if you want. You should. Okay, so, like that, right? Yes. Thank you. Sorry about that. I appreciate the nits. Somebody's got to pick them, right? Okay, and then the last one there is the most complicated. I actually have some things to say about this last one, so let's try and draw this one. Maybe I'll try and draw this one nice too, where they all go across the bottom. I'm gonna end up with A A A, B B, A A A. I don't know if I can actually fit it in there. Okay, let me. Is this gonna work? Kind of. Trying to get too fancy here. Okay, so S goes to ASA, gives me these guys, right? And then the middle S also, actually two more of those, right? S goes to ASA, and then another. And then the S here turns into a T, and then that T gives me a BT and a B. All right, plenty of room. All right, I hope that's what you got on your homework or on a quiz or something. I don't care if you write it in this sort of nice way, although it is nice. I like nice things. We can have nice things even in a math class. I have some terminology having to do with parse trees. All right, we're not really just doing this for fun. The parse trees is the main idea behind the pumping lemma for context-free languages. So some terminology here. All right, we can analyze sort of pieces of this tree according to the non-terminals on the inside. So each non-terminal has what we call, and you will know what I mean immediately when I say this, has descendants, right? That is just everything which lies below it in the tree. So for example, this S right here, its descendants are all the things underneath it. So that's all of this stuff, right? That S in the middle has certain descendants. And the other S, say the one S above, has a different set of descendants, right? It's got like bigger, more stuff. But anyway, here's some more terminology here. That S, we say this S generates the non-terminal string, in this example, ABBA, right? If I consider only that S, you can look at only its descendants, and if you go all the way to the bottom, it generates part of the string that you end up with, all right? And this is the terminology that we're going to use for that. We say S generates the non-terminal string ABBA. What I mean by that is if you follow that S and its descendants all the way down to the bottom, it creates part of the string. In this example, that part is ABBA. All right? Whereas, for example, this right rather than that S, this S, right immediately below it, this S generates, what's the string that that one generates? BB, right? If you only follow that S down, then the string that you see at the bottom is BB. All right, that's because you would only looking at this part. That S generates the string BB. Okay, every non-terminal generates a part of the string. The one all the way at the top, the S at the very top, that generates the whole string. But the other ones, as you go down, they generate other pieces. Now the T under the S that I just circled also generates BB. So it's not necessarily like unique to those interior non-terminals. All right. You can see, based on this this way of talking about things, you can see why actually it is important that the grammar be context-free. So the grammar must be context-free in order for this to work. If it's not context-free, then it messes up the whole concept of doing parse trees. Somebody say something in the chat or in the Zoom? No, I heard something. If the grammar is not context-free, it messes up something about the parse trees. For example, if I had, here's a non-context-free grammar. S goes to A, B, S, or epsilon. And then here's the non-context-free one. BS goes to SB. Right? This should strike you as very weird. Usually we don't put weird things on the left side of the arrow like that, but that's because we usually talk about context-free. This is not context-free. In this grammar, we can derive AABB. Does anybody see how to derive AABB? I'll do the first step. S goes to ABS. You shouldn't go to epsilon right away. Does anybody see how to get AABB? Yeah. Okay, now do BS goes to SB. All right, so it's now ASB. Yeah, then do the first one again. S goes to ABS. So this is now A, ABS, B. And finally, yeah, now S goes to epsilon. Great. Okay, so you can derive AABB using this weird grammar. It does require the weird step, though. The BS goes to SB. All right? But check it out. What if I try to represent that derivation on a parse tree? I go S at the top, and then ABS. Okay? Now, BS goes to SB. On the tree, you actually can't draw that as sort of S now becomes something else, right? The best you could do on the tree is somehow there's some kind of quantum shift or something. The B and the S, they somehow interchange places on the tree. And then I guess you could continue if you really want to. A, B, S, and then the S becomes epsilon, right? Now, maybe you're wondering, well, is that so bad that I sort of crossed the streams? I drew them as real squiggles, but maybe I was just being demeaning. Is it so bad to just do that inside the tree? The answer is, yeah, it kind of is. I mean, you mess up the structure, I could ask, okay? Still with me here? Yeah? I don't know what that was all about. It messes up the descendants structure, right? For instance, if I ask you what are the descendants of S, and what part of the string does that S generate? It's not clear, actually, should the descendants of S include this B or not? Something crazy is going on with my screen here. I don't know what's up. Can I just say, in such a tree, I mean, this is not really a tree anymore, but in such a grammar, the descendants are not really well defined. All right. I only did that weird grammar step once in this case, but you can imagine, if I use that step several times going down the tree, it totally messes up the tree, and it doesn't even really make sense to think of it as a tree anymore. If you can somehow swap the branches with one another in the middle of the tree, that's not, I'm not trying to hear that, see? That's not how trees are supposed to work. All right, so all of that just to say, it is important that it's context-free, and what we're about to say really doesn't work at all unless the grammar is context-free. I don't know what's going on with my screen here. Sorry about that. I hope it's got to hold it together for 7 more minutes, okay? Here's something interesting about a parse tree. So from now on, only context-free languages. Parse trees for particular strings. Come on back. It's really stuck now. I only got 6 minutes here. Oh, okay. I don't know what's going on here. I can see writing on my screen, but it's not on there. Sorry about this. I'm going to pull the plug and put it back in and see if that does it. Did you see that? It appeared as soon as I pulled the plug. I don't know what that's all about. I'm using QuickTime and piping it through OBS so that I can record nicely. Yeah, it's like an overly complicated setup, but I think it does everything that I want. Okay, I'm better now. All right, we'll see. Anyway, parse trees for particular strings can be pumped. All right, this is the word. This is the real word. I'm not making this up. This is how people describe it. You can pump part of the parse tree. Here's what that means. If I have, for instance, S, this is not the same grammar. I'm just making up a parse tree. I don't even know what the grammar is that it comes from. Not important. Let's say Y goes to B, Y, A, and then this Y goes to epsilon. All right. This is a parse tree. The string here is A, B, B, A, I guess, right? There's an epsilon in there, but the string is A, B, B, A. This is not pumped. I'm about to show you what it looks like when you pump it, okay? When you pump it, what pumping is all about is when you see a non-terminal, which is a descendant of itself. In this case, we have a Y, which is a descendant of another Y. So when one non-terminal is a descendant of itself, we can, if we want to, pump it. And what that means is you take this whole descendant tree for the upper Y, and you plug that entire tree in for the lower Y, all right? So I'm going to substitute where you see the Y down here. I'm going to plug in the entire picture that you see from the upper Y. I don't know if that sounds complicated. It's not really. So it becomes, the S is still up here. The X side of the tree is all going to be the same. I'm only changing the part where I put the circles. And what you do is, so you keep the upper Y like it is. But then the lower y, I am substituting in, plugging in the entire descendants of the upper y. It looks like this. So this circled part is the same as that circled part. All right? Did I draw that right? I think I did. The lower y is being replaced by the original descendants of the upper y. All right? This is called pumping the y. It's called, I don't really know why it's called pumping, but maybe one reason is you can keep on doing it as many times as you want, right? You can pump it again. That would mean you replace this part of the picture, this y here, you stick that whole thing in there again. But the point is, this string, the string that I derived here, so the string is now, what is it? It's A, B, 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 A, right? It has an extra B in it. And so whatever language we started with, just by looking at the parse tree, you know that ABB was in L. In this case, ABB was in the language that I started with. After pumping it, we also know that ABBB is also in the language. All right? So the moral of the story here is pumping can derive more strings. And in particular, these strings will always be longer. Like in this pumping thing here, we're going to talk more in detail next time, but if you think about it, every time you pump this, I said you could continue to pump it over and over, it would always insert another B, right? So in fact, in this example, actually, this really constitutes a proof that these strings are always in the language because you could pump over and over again and you would be able to generate any of these other strings. This is the basic idea behind the pumping limit is if you look at parse trees by pumping certain parts, it can tell you a lot about what the language is, even if you don't even know what the grammar is or anything, right? Pumping can derive longer strings. Let me just finish the sentence. I meant to say, in the language you're talking about. All right, all of that we will continue next time. Have a good weekend. Yes.
The
quiz?
read, pop, push. Yeah, just for number one.
Yeah.
But I think I was assuming that there was like AA, epsilon. Could you not have done that for the derivation? I just forget what this is. I can't write it down.
So you used AA epsilons up here?
I think, yeah, I did. And BB's epsilons. I was just wondering.
Yeah, it wasn't there. Like you shouldn't have. Seems to me you turned this into a grammar,
Yeah, I did.
and then you use those grammar steps to make
This.
and
I don't know if it's the same thing.
it seems like you use these grammar steps to create another stack machine, which you didn't actually write down, and then you use that other stack machine to do this.
Okay.
Because like that other machine, it would have things like B, B, epsilon.
So this grammar is not equivalent to this then?
It is, but the stack steps you're using are not actually these steps. You're using steps like in the first line, you used a step like epsilon s a s x, but that's not a grammar.
That's not a step in there.
That's not a step on this one. Yeah, you invented another stack machine which is equivalent, and then you did the derivation using those other rules.
Okay.
So, it's something. I'll probably take off 2 points.
Sounds good.
Yeah.
I think I've just gone on to like the trend of just assuming that you do like AA, epsilon or whatever.
Right. I think you probably were hoping to get a question like that, and so you
I just had it in my head.
You forced
yeah.
it into that, even when it wasn't really what I wanted.